Will the Milky Way and Andromeda galaxies collide, or will they narrowly avoid one another, leaving our solar system intact? Let's unravel this cosmic mystery. The Andromeda galaxy is hurtling towards us at a speed of 110 kilometers per second. It seems like an inevitable crash. But is it? When galaxies like Andromeda and the Milky Way collide, chaos erupts. Stars are flung into space. Gas clouds crash into each other, and black holes at their centers begin to devour material, igniting with the energy of millions of suns. Despite the violence, very few stars actually collide directly due to the vast distances between them. But the orbits of stars will shift dramatically, changing the structure of both galaxies forever. Scientists predict two scenarios: a direct collision, which would merge the Milky Way and Andromeda into a new galaxy, or they may pass closely by, avoiding a disastrous encounter. Andromeda is a faint smudge, visible only to those who know where to look. However, over billions of years, it will grow, dominating our skies as it approaches for a potential galactic collision. What does this cosmic event mean for us? In a galactic collision, entire solar systems can be displaced, even ejected into intergalactic space. Our solar system could be one of the unlucky few, hurled away from the Milky Way, drifting alone in the cold, dark expanse between galaxies. By the time the two galaxies collide, the surface of the Earth will have already become far too hot for liquid water to exist, due to the gradually increasing luminosity of the Sun, ending all terrestrial life. To predict Andromeda's future, we need to understand its velocity in two directions. The velocity of an object can be broken down into two component directions: how fast it's moving toward or away from you, called the radial velocity, and how fast it's moving to the side, the transverse velocity. If something has some velocity toward you and zero transverse velocity, brace for impact. But if it has some positive transverse velocity, then it's moving sideways as well as toward you. If the transverse velocity is high enough, then it'll miss. Measuring Andromeda's radial velocity is straightforward due to the Doppler effect. As Andromeda moves toward us, its light shifts to shorter wavelengths, blue shifting. By analyzing the galaxy's spectrum, scientists have measured this speed at about 100 kilometers per second. But what about its sideways motion or transverse velocity? This is much harder to measure and could be the key to whether we collide or miss. The data from the Gaia spacecraft show Andromeda moving sideways at 82 kilometers per second, which could mean it's on track to miss us entirely. But here's where things get complicated. The uncertainties are very big. Means both scenarios, collision or near miss, are still possible. Another consideration made by scientists is the possibility that nearby galaxies, such as the Large Magellanic Cloud and Triangulum, could tug on the Milky Way or Andromeda just enough to result in a near miss. These next two are the Large Magellanic Cloud, a satellite of the Milky Way located about 160,000 light-years away, and the Triangulum Galaxy, M33, which is approximately 2.7 million light-years from the Milky Way and only 700,000 light-years from Andromeda. They lie close together in the night sky. The local group is dominated by these four. Scientists have run countless simulations, tweaking variables like speed and gravitational influences. Nearby galaxies, like the Large Magellanic Cloud, play a critical role in this cosmic dance. Some simulations show that their gravity could pull the Milky Way just enough to dodge a collision, while others show that they could tug us right back into Andromeda's path. Researchers found the galaxies collided slightly less than half the time. If the galaxies do collide, they will merge into one supergalaxy, sometimes called Milkomeda. This new galaxy could experience a burst of star formation as gas clouds collide and collapse, creating millions of new stars. It would be the birth of a new cosmic structure, one that might even last until the end of the universe. Whether a collision or a near miss, this event won't happen for another 5 billion years. By then, Earth might be long gone, but the universe will keep dancing to its cosmic tune. There is a center supermassive black hole in both the Milky Way and Andromeda. It may take millions of years for these black holes to spiral into one another and eventually converge close to the center of the newly created galaxy. Upon approaching each other within a light year, the supermassive black holes will start to strongly produce gravitational waves, which will continue to radiate orbital energy until they merge entirely. An active galactic nucleus could be formed by the gas that the merging black holes absorb. An unfathomable amount of energy would be released if this occurred. A catastrophic collision or a near miss? The fate of the Milky Way and Andromeda is written in the stars, waiting to be revealed.